series and their notations. So here's a definition. The sequence of what we call partial sums is defined as basically adding up all the terms in a sequence. So capital S sub 1 would just be the first partial sum or just the first term by itself. Capital S sub 2 means that we've added the first two terms, called the second partial sum, and so forth. So when we talk about a series, we are talking about a summation. So the sum of the terms of a sequence is called the series, not the World Series, the summation series. So the sum of the first n terms of a series can be expressed using a summation notation, which uses the capital letter sigma. We've got the sigma notation. The very top n tells us how many terms we're working with, basically. It tells us to end when the k equals n. The k in the bottom tells us that we're starting with 1. Now, you may see summations in the future where the k starts at 0 or it starts at a different number, but it's usually 0 or 1. The sigma itself tells us to add. So think of the sigma capital S for sum. So if you have this little k here, that's what tells us where we're going to plug in those values of k, where k equals 1, k equals 2, and so forth. So that summation is read as the sum of a sub k from k equals 1 to k equals n. So the letter k is the index of summation. Okay, a lot of times we just call it the index, and 1 is the lower limit, and the n is the upper limit of the summation. So our first example, in this example, hey, look, our k is not starting with 1, it's starting with 2. So what this is telling us is that we're going to plug in 2, we're going to plug in 3, and we're going to plug in 4. You're still using your counting numbers, your positive integers. So our first term would be 2 times 2 plus 1, and we're going to add that to the 2 times 3 plus 1. And then we're going to add that to 2 times 4 plus 1. So basically it's telling us to use the second term plus the third term plus the fourth term. So when we simplify that, the first one gives us 4 plus 1, which is a 5. 6 plus 1 is 7. 8 plus 1 is 9. So notice we had a nice linear equation there, and we end up with a nice arithmetic sequence. 5, if we had commas, 5, 7, 9. But now we're adding them all together, and that would give us what, 21? So this summation here equals 21. Now, I do know there is a summation in most of the graphing calculators, if not all of them. I don't mind you using your calculator to check, but I want to see your work. Just like with the graphing and finding intercepts, you can graph it to get an idea to check your work, but putting it in your calculator is not considered work. Remember, some of you guys are going to be designing some computer programs. You can't design it based on another calculator program necessarily, so you need to know how it's developed yourself. You need to know how it works, and that way you can check your work, okay? And recognize any, human error. Let's take a look at B. Express the sum below in summation or sigma notation. So we're going to go backwards. This means that we need to know which term we're starting with, which term we're going to end with. So if this is the first term, second, then we know we're going to go from the first term to the 7th term as far as we know. That might change, but it's a good start. We're going to go from 1 to 7. But then we need to figure out what is the formula here. Okay, what is it? Is it arithmetic? Again, ignore the plus signs for a second. Look at the pattern. When we go from 1 to 4, we're adding 3, but from 4 to 9, we're adding 5. And then from 9 to 6, we're adding 7. So we're adding an increase in number every single time. That's not arithmetic or geometric. We're not multiplying. So let's see if we can determine another pattern. 1, 4, 9, 16, 25, all of these numbers have something in common. Not a GCF, but all of them happen to be perfect squares. So notice if I were to rewrite each of these, 1 is 1 squared, 4 is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. So if you don't see a pattern as far as arithmetic or geometric, look to see if there's a relationship with the n. In other words, the first term, 1 and the first term. Well, your second term is the relationship with the number 2 in that term, third term, 3 in that term. So in all of those, it's the term squared. If you're the 5th term, then it's 5 squared. If it's the 7th term, then it's 7 squared. If we went out to the 10th term, it would be 10 squared. So the formula there is the fact that we're taking n and we're squaring it. So since we're using k here, then we would use the formula k squared. Now, you may see some summations where they use I, so don't get this confused with complex numbers. It is purely context. Okay, so if you see it within the sigma, then it's not a complex number. So you might see it like this, I squared, or they might actually use the n. N goes from 1 to 7, n squared. So it's not always k, all right? So if you're doing your homework, be sure you're paying attention to whether they're asking or using the k and I or an n in that formula.